Welcome to thermodynamics. Hello everyone, my name is Sahithi. I am pursuing BSc Computers second year at Spaces Degree College. Today I am going to explain about thermodynamics and first law of thermodynamics. Firstly, what is thermodynamics? Thermodynamics is a branch of thermal physics which explains the transformation of thermal or heat energy into mechanical energy and vice versa. That is thermal energy to mechanical energy. And in this, what is system? A definite amount of matter which is bounded by some closed surface is known as system. Example, a gas container. And in this, what different types of systems? Open system, closed system and isolated system. Firstly, what is open system? A system which can exchange both energy and matter with the surroundings. And closed system, a system which can exchange only energy but not matter with the surroundings. And isolated system, a system which can't exchange both energy and matter with the surroundings is called isolated or ideal system. Surroundings, all those things which are behind the system and which can influence the system are called surroundings. These are the examples of different types of systems in thermodynamics. Coming to first law of thermodynamics, this law explains about conservation of energy. The general form of first law of thermodynamics is when a definite amount of work is done, then certain amount of heat energy is released by the system and vice versa. Here work done is directly proportional to heat. Then work done equals to some constant into H. J equals to mechanical constant equals to 4.2 joules per calories. This law explains about equivalence between mechanical work and heat energy. Here, this is also called Joule's law. The actual form of first law of thermodynamics is proposed by Calcius in 1850. That is, dQ is the amount of heat energy given to the system, which is useful to explain the following three parts. Some part of heat energy is used to raise the temperature to increase its internal kinetic energy. It is denoted by dQ suffix k. And some part of heat energy is used to do internal work against molecular attractions, which is useful to increase internal potential energy. It is denoted by du suffix p. The remaining part of heat energy is used to do external work. It is denoted by dW. That is, dQ is equals to internal kinetic energy plus internal potential energy equals to external work. Here dQ is equals to du suffix k plus du suffix p. Then dQ is equals to du plus dW. Here the first law of thermodynamics also defined as the amount of heat energy given to the system is equal to the sum of internal energy and work done by the system. And now, significance of first law of thermodynamics. There are three basic ideas which are related to first law of thermodynamics. They are: heat is a form of energy. Heat flows from hotter body to colder body, and energy is conserved in any thermodynamic system. And every thermodynamic system in equilibrium condition exhibits internal energy is function of state of the system. And next important points are: all the quantities must be expressed in same units, either in Kelvin or Celsius. The increase in internal energy should be taken as positive dQ and decrease of internal energy should be taken as negative dU. And heat energy is absorbed by the system is taken as positive dQ. Heat energy is rejected by the system is taken as negative dq. Work is done by the system should be taken as positive dw, while the work is done on the system should be taken as negative dw. Then some note points. For adiabatic process, dq is equals to 0. So dq is equals to du plus dw. Then substitute in this equation 0 equals to du plus dw. Then du equals to minus dw. For isothermal process, temperature equals to constant. Then change in temperature equals to 0. We know that du is equals to C suffix v into dt. Then du equals to 0. The first law of thermodynamics, dq is equals to du plus dw. Then dq is equals to 0 plus dw. Then dq is equals to dw. These all about first law of thermodynamics. Hope you all understood. Thank you all.